All right, hello everyone. So this is a lab review on general science majorship, and it covers the introductory part, refresher for the following topics. Okay, you have nature science, inquiry processes, scientific method, science, and technology. So the first 1 to 25 covers A and B, and then part 1 and 2 will cover C and D. Okay, to start with, which best describes science as a human endeavor? So your answer here, it is not A. Why is A wrong? It is because it says absolute truth. Science is ever evolving, so there's no such thing as absolute. Okay? And then letter C is wrong as well. It says fixed set of facts stored in textbooks. Again, science is dynamic. And then it says letter D is wrong as well. A method limited to laboratory experiment. That's wrong as well because science is a method that is more on a thinking process and theory, right? Not just in laboratory. And then the correct answer, of course, is this one, a dynamic process of building knowledge through inquiry. So when we say that science is not a collection of absolute truths, rather, it is dynamic in nature, which makes science self-correcting and reliable over time. Okay? Next, item 2. The statement science is tentative means that scientific knowledge, tentative, the word tentative. So the answer here uh, is letter B, can change when new evidence is discovered. It cannot be A. It is not always wrong, and unreliable, of course, it's wrong. It's only valid, of course. Science is universal. So if it's correct on this country, it's also correct on Eastern, right? Never applies to everyday life. Of course, science is applied in daily life. So it's letter B. Can change when new evidence is discovered. Item 3, which characteristic of science emphasizes that results must be reproducible by others? What's the answer for this? The answer is reproducible. So it should be replicability. Never mind that. All right. So yeah, why replicability? So it is very essential because it protects science from fraud, error, and bias. If only one person can ever produce a result, that's why when you conduct a research, one of the common recommendation is that the experiment or the study be conducted again, but this time in different size of population or sample, so that you can say that the result is accurate and precise. Okay? Repli- Replicability ensures that findings are not accidents or fabrications. That's why serendipity is wrong. Subjectivity is wrong. It should be objective creativity, not the most correct answer. Okay? A scientist observes that plants grow faster near windows. This is an example of, is it law, theory, observation, or hypothesis? Observes. Of course, it is observation. Okay? When we say observation, it is a statement based directly on the senses or instruments, what you see, hear, smell, taste, or measure. Okay? When you say law, it has been tested over several trials, so it's always correct. A theory, not tested in a larger sample, universal sample. Okay? Hypothesis, of course, the wild guess, the smart guess, the wise guess. Okay? Next one. Scientific laws differ from scientific theories in that laws. What's your correct answer here? Number 5. So the correct answer is describe what happens under given condition. So scientific laws are concise statements that describes consistent patterns in nature. For example, the law of gravity or Boyle's law, they tell us what happens reliably. So it explains why phenomena occur are less reliable than theories. Of course, it is way more reliable than theories. Apply on its own, no, so it's not. It's letter B. But theories, on the other hand, explain why and how things happen. Okay, so this is theory. Letter A describes more the theory. They provide the underlying mechanism compared to the law. Neither is more reliable than the other. They serve different purpose. So whether it's law or theory, they have different purpose. The next one, which best illustrates the empirical nature of science? What's your answer? A, B, C, or D? The correct answer is letter B. Drawing conclusions based on sensory evidence. Okay? So, the empirical nature of science means that all scientific knowledge ultimately rests on observation and experimentation. That's why it is empirical, it is measurable. The claims must be grounded in evidence that can be perceived and tested. That's why it is different from philosophy or religion, which may sometimes rely on reasoning, faith, or revelation rather than observable evidence. Okay? So, of course, C is not. No, no. Okay, that's letter B. Next one, the idea that science is socially and culturally embedded means socially and culturally embedded. What's your answer for that? It is letter B. Societal values and culture can influence scientific priorities. Of course, A is not. No, no. Okay. Right. Next, you may pause if you want to answer before I share the answer. Which of the following is not a nature of science? Tenet. So you have here A, B, C, or D. What's your answer? All right. The correct answer here is letter C. Scientific knowledge is always certain and final. It says not. Okay, that's why this is the correct answer. Okay. Because all other options, empirically based, requiring creativity and cultural influence, are recognized tenets of the nature of science. So, therefore, the idea that science produces permanent, unchangeable truth is a misconception. Scientific knowledge, remember, is always provisional, always subject to refinement or replacement based on new evidence. Next, peer review in science primarily serves to what? What's your correct answer here? The answer is letter B. Validate and check the quality of research before publication. Next, a distinction between science and pseudoscience is best illustrated by, what's your answer? Letter? Letter C. Sorry, letter B. So science makes testable, falsifiable claims. Okay? Pseudoscience does not. Okay. So when I say falsifiability is proposed by philosopher Karl Popper, it is the criterion that a claim must be capable of being proven wrong by evidence. That's why this science makes testable, falsifiable claims. And for astrology, for example, makes vague predictions that cannot be clearly tested or proven. This pseudoscience. Evolution, by contrast, makes specific predictions that could, in principle, be falsified. This testability is what makes science trustworthy. Okay? Which inquiry skill involves grouping objects based on shared characteristic? What's the answer? It is, of course, shared characteristic. It is classifying shared characteristic. Next, a student predicts that adding fertilizer will increase plant height. This is an example of what? Predicts. The answer is, of course, predicting. Anyway, this is just a refresher. Alright, after watching ice melt, the student concludes it absorbed heat from the surroundings. This is what? Okay, what's your answer? An inference. So when I say an inference, this is an interpretation or explanation that goes beyond what was directly observed. So for example, watching ice melt is the observation. Concluding that the ice absorbed heat from the surroundings is an inference. It is a logical deduction. Okay? That is what we mean by that, based on the knowledge of thermodynamics. But inferences can be wrong, and therefore they must be tested, unlike observations, which are direct records of reality. So that is an inference. Again, watching ice melt, that is observation. But concluding it, that's an inference. Okay? It is not yet yeah, whatever. Which process skill involves using numbers to describe observations? Numbers. So that is measuring. Okay. An integrated process skill that combines data and observations to formulate explanation. Integrated process skill. So what is that? That is interpreting data. That is the answer. Because you are going to formulate explanation, and therefore you have to collate the data and then observe and interpret. Which inquiry skill is demonstrated when a student draws a graph from experimental data? What's your answer? Okay, it is communicating. So, communicating is the process skill of sharing scientific findings with others through writing, graphs, tables, diagrams, or oral presentations or report. So, this one is very essential skill because knowledge must be shared to be validated, built upon, and applied. So drawing a graph from data is a form of visual communication. Again, a graph is a form of visual communication. Next, operational definitions in science are important because they operational definitions. What's that? It is answers letter B. Specify exactly how variable is measured in a study. What do you mean by that? When we talk about operational definition, it gives precise, measurable meaning to concept within the context of a specific experiment. For example, plant growth might be operationally defined as the increase in stem height in centimeters over 2 weeks, so it's something like that. So this ensures that all researchers measure the same thing the same way. So it makes the experiment replication possible. So it is reproducible, okay, or replicable, okay. Next, a student uses a spring scale to find the weight of a stone. Which process scale is being used? What's your answer for number 18? So for number 18, that is weight. Find the weight measuring. Which of the following is a basic process skill, not an integrated one? Basic process. So number 19 should be observing because controlling variables, it involves measuring, inferring. No. So this one interpreting, it collects all the data, forming hypothesis. So the correct answer, I'm sorry, the correct answer is observing a basic. So mean to say it only involves your senses. Constructing a model of the solar system to show planetary distance is an example of constructing a model. That is, of course, modeling. In a controlled experiment, the variable that the scientist deliberately changes is called the what? Deliberately changes. That is independent variable. So the independent variable is the one factor that the researcher deliberately manipulates in order to observe its effect. It is independent because its value does not depend on any other variable in the experiment. So, for example, in a study on plant growth and light, the amount of light given to each plant is the independent variable. Okay, next one. You have a hypothesis must be testable and falsifiable. So again, when we say blah 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 blah. All right. So when we say falsifiable, it means it can be tested through observation, so it can be proven wrong. Okay. Which step immediately follows data collection and scientific method? Analyzing and interpreting data. What comes next to that? All right. The purpose of a control group in an experiment is to what? Is to serve, receive, ensure, eliminate. So the answer is serve as a comparison that does not receive the treatment. So the purpose of the control group is the one that is being kept under the same condition as the experimental group, except that it does not receive the independent variable being tested, right? That's it. So next one, repeating an experiment multiple times increases reliability and validity of results. Okay, so that's for. So the next video is all about the continuation of scientific method, and then science. What's the next one? So letter D, science process skills, part 1 to 2. Okay,